Question 49. Which of the following describes the total number of dots in the first n rows of the triangular arrangement below? Alright, so we'll treat this as our input variable n, and if we want to figure out how many dots are in that row, let's see, there's 2 here, 4, and then it looks like 6 and 8 and 10, right? However, that's not quite what they want us to figure out, okay? What they want us to figure out is the total number of rows of the first, total number of dots in the first n rows. So in the first one row there's 2 dots, but then in the first 2 rows there is a total of 6 dots, right? And then in the first 3 rows combined there's a total of 12, right? 6 plus a new 6. Then 12 plus a new 8 gives me 20, and 20 plus a new 10 gives me 30. So this is going to be my totals, okay? So when my input is 1, I expect to get an output of 2, but when my input is 5, I expect to get an output of 30, right? So we can sort of erase these. So let's see which of these formulas has that correspondence, okay? So when n equals 1, I need 2, so that's not going to work. If I plug in 1 here, I get 2, so that works. If I plug in 1 here, 1 squared is 1. No good. Plug in 1 here, I get 1 times 1 plus 1. So that's 1 times 2, which is 2. That works. And then if I plug in 1 for choice E, 2 times 1 is 2, plus 1 minus 1 is 0, 0. So also works. Okay, so next I'm going to have to try another input letter. So let's try plugging in 5 to the remaining choices, and I hopefully will get 30 out as a result. So if I plug in 5 here, I get 10. That's no good. Okay, so then if I plug in 5 here, I get 5 times 5 plus 1, which is 6. 5 times 6 is 30, so that one works again. And then if I plug in 5 on the bottom, I get 2 times 5, which is 10. 5 minus 1 is 4, 4 times 2 is 8, 10 plus 8 is 18, which is not 30, so the only one that survives is choice D. After polling a class of 24 students by a show of hands, you find that 9 students play soccer and 21 play basketball. Okay, so this is looking like a Venn diagram question. Okay, soccer and then basketball. And this is going to be the both category, okay? So the number that plays soccer we place outside, not inside the circle. So the soccer is 9 and the basketball is 21. Given that information, what is the number of students of the class who must play both? So we're looking for both, and the class has 24 students total. Alright, so the idea is that when we add S and B, okay, of course we are going to get 30. And then, but our total is only 24, so if we subtract these, we end up with 6, and that's how many has to go in the middle. Okay, so it's a simple algorithm. You just take this soccer plus basketball, that would be 30, and then subtract, the total is 24, you get 6. Now let's look at why that works. So really, S, right, the soccer players, covers sort of the left plus the middle, if you will, where this is sort of the left, this is the middle, and this is the right. And then when you do B, right, B is really middle plus right. Okay, let me actually stagger this a little bit, so that when I add S and B, right, S plus B, that's going to equal left plus twice middle plus right. So what we learn here is that when we add S and B, it counts the middle twice. Okay, now this number here, 24, is just left plus middle plus right. Okay, left plus middle plus right is just going to be that number 24. Okay, now S plus B, of course, was 30. So then if I subtract 30 and 24, I get 6. And if I subtract L and L, that cancels. 2m minus m is just m. Right and right cancels. So I learned that the middle is equal to 6. Right, so that's a little proof. Next, which of the following is the set of all real numbers x such that x plus 2 is greater than x plus 5? Okay, so my first step here is I'm going to subtract x from both sides. Right, they are like terms after all, And a lot of people might freak out at this point, thinking they did something wrong. But no, you didn't do anything wrong. You know, you follow the rules of math, and you end up with this. So at this point, you know, you can interpret it from here, or you can combine these by subtracting 2. But let's interpret it from here. So the question is this true or false? Right? So is 2 greater than 5? The answer is no. It's false. Right? So we learned that this is a false statement. Now notice that there's no x. X dropped out altogether. So this does not even depend on what our choice of x is. Okay? So that means no matter what x is, this statement is always going to be false. Right? So therefore, the only way to make it true, well, there is no way to make it true. Right? The only x's that make it true is the empty set. Right? Next, pentagons have 5 diagonals as illustrated below. How many diagonals does the heptagon have? So you might try to think of a formula that relates the number of sides to the number of diagonals, but that might be a little bit much. Okay, so instead, let's just try to draw all these diagonals. So we'll start with this point, and you don't want to draw the ones that are already attached. You only want to draw the extra ones. So 1, 2, 3, 4. So we get 4 from that vertex. Now we go ahead and start from this vertex, and we can draw 1, 2, 3, 4, and those are already drawn. Okay, and then now we're going to start from this vertex. Notice that one of these purple lines is already drawn out of those 4, so it's probably going to only have 3, right? 1, 2, 3. Okay, now we go to this section here, and notice that 2 lines are already drawn to this vertex. So when we draw it, we're going to go 1, 2. Okay, and finally we look at this point here, and it has 3 lines emanating from it, so we're probably only going to get 1 line out of this guy, right? 1. Right. Okay, and then when you look at this guy here, he's got all 4 drawn already, so there's not going to be any more than that. And this guy here has got all 4 drawn already, so there's not going to be any more from him. So 4, 8, 9, 10, 11, 12, 13, 14. So I'd go with answer choice H. Now if you're curious as to what the formula might be, right, we can think about the situation for a generic amount of sides. Okay, so let's say we have an n-sided polygon. Well, the number of lines I'm going to be able to draw from this first vertex is going to be however many sides there are minus 2. I think. Let's see if that's right. So heptagon has 7 sides. Well, actually it might be minus 3, because you can't draw to itself, and you can't draw to any of its direct neighbors. So there's 3 that are no good, but then there's 4 that are good, right? So n minus 3, and if I was to do that from every single vertex, I would multiply this by 7, right? But then I would be double counting each line, you see. So I'd have to then divide that by 2. And I think this formula might work. So let's check it. So for the case that n equals, so this won't generally be 7, it'll in general be n, right? So for the case of n equals 7, I would get 7 times 7 minus 3 is 4 over 2, 4 over 2 is 2, 7 times 2 is 14, so that works. For the case of n equals 5, right, I would get 5 times 5 minus 3 is 2 over 2, those cancel, so I would get 5 diagonals, yeah, so 5 diagonals and then 14. So it works for the 2 test cases that we've seen here. John wants to draw a circle graph showing his friends' favorite ice cream flavors. When he polled his friends asking each their favorite flavor of ice cream, 35% of his friends said chocolate, 20% said vanilla, 15% said strawberry, 25% said mint, and 5% said other. What will be the degree measure of the vanilla sector of the circle? Okay. So when we're talking about sectors of a circle, right, basically it's going to be degree measurement that's out of a total of 360. So it's going to be something out of 360, right? And percents, of course, are out of 100. So the percent that corresponds with vanilla is 20%. So 20% out of 100 is x out of 360. And then we just have to solve the proportion. Okay? So we move this 360 diagonally across the equal sign. Okay, lands there. Then we can start canceling out zeros. So those zeros can cancel. Right? Oops. And also these zeros can cancel. Come on. 1 doesn't do anything, so just 2 times 36, which is 72. So that's how many degrees will be in that arc, or central angle. Right, so if sine theta equals 4/5 and theta is between pi over 2 and pi, then tangent of theta is what? Okay, so what is this telling us? Well, basically, pi is 180 degrees, right? And half of that would be 90. So in degrees, it's telling us that the angle is between 90 and 180. We always measure with respect to the positive x-axis, so this would be a 0 degree angle, this would be a 90, this would be a 180, right? Alright, so anyway, yeah, 90 and 180. So we must be in quadrant 2. Okay, so we can draw our sort of line and then make our reference triangle here. So this is our right angle. This is our reference angle, which is not really theta, but it's theta r reference. But they have equivalent properties, so we can just leave it at that. Now, if we want the sine of this angle, and again, we can just call it theta for now, it's going to be 4/5. So that, according to SOHCAHTOA, right, is going to be opposite over hypotenuse. So, from this angle's perspective, the opposite side is 4, and the hypotenuse is 5. And we can actually figure this third side out using Pythagorean theorem, or we can use the idea of Pythagorean triples. So we know 3, 4, 5 is 1, and the 3 seems to be the missing side, so we can put that in here. Okay. Next, we would want to get the tangent of this angle. So the tangent is known as the opposite over adjacent. So the opposite is going to be 4, the adjacent is going to be 3, so 4/3, right? Now the only thing that we have to check is whether it's positive or negative 4/3, right? So sometimes people will put anything that moves to the left as negative, so then you get -3. Anything that moves downwards will be negative, but the hypotenuse will always be positive, okay? So if you did that analysis, you get negative 4/3, right? Alternatively, you can use the Astc method. ASTC, right? So all students take calculus is the mnemonic. Now, A stands for all, meaning all are positive. S stands for sine, meaning only sine is positive in this quadrant. T is tangent, C is cosine, right? So it tells you what's positive. So in quadrant 2, which is where we are, the sine is the only thing that's positive. So the tangent, therefore, must be negative. And so using that logic, we can again decide that it's a negative value. Which of the following systems of inequalities is represented by the shaded region of the graph below? Alright, so in this case, first thing we'd like to do, perhaps, is to find out which equations are involved. Okay, so we use the concept of y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so starting with the y-intercept, we can note that this has a y-intercept of 1. So it's going to have a +1, and the slope we could learn whenever we look at 2 points of known value. So we can march up 1 and over 1 to get to the next point. So that means the slope is 1. So we can just put x. So the first line is y equals x plus 1. Okay. Which these all have. So that didn't really help very much. Now, with this, when it comes to the shading, of course, you notice that we're shading downwards. So that would be less than. Okay. And still, that doesn't help. Okay. So we'll have to look at the other line. Now, the other line's intercept is down here at -3. And we can determine its slope by looking at this and this. Now, it seems as though we have to march down 3 and then over 2. So down 3 over 2 in front of the x. So here is our equation. Alright, so now we can eliminate some choices. namely A and B, right? Then we just have to decide about the inequality sign. So it looks as though from this perspective we're shading upwards, right? So that would be a greater than. So we can eliminate anything with less than, which is this. So we're down to C and E. So we have to spot the difference. And it appears the difference is here in the middle. So am I concerned with solving this, or is it this and this? Well, I claim it's and, right? So I have to satisfy both conditions simultaneously in order to be in this quadrant, right? If it was an or situation, then, for example, this region would also be part of my solution space, seeing as it's below the first line. But it doesn't satisfy both. We are only interested in the region that satisfies both, so we need and.